Okay, everyone, Praxis reported the alien clown zombies are still getting dropped. It's been a week, we haven't had any power, things have been bad. So, snuck out last night, scrounged together anything I could find to make a solar system. It's the bare minimum, but it should work. Let me show you what I got. Welcome everyone, welcome to Moy. This episode, I wanted to go over a very, very basic solar system. I mean, the absolute minimum we needed to make some sort of solar work. And it is the bare minimum. It comes from a lot of my leftover solar parts, just like that. I actually keep two solar systems around. The reason is when you're working on one, it's nice when you have electricity to see what you're doing with the other. So it's good to keep a little old school solar system. This one is 12 volt. And what we're gonna do is start with the absolute basics, show you how it works, and then we will add to it and make it pretty spiffy. This is gonna be a series of videos. I hope you all like it. Okay, so down here, we're looking at just some basic components. And what we have is a battery, an inverter, solar charge controller, 12 volt power output, and an outlet for running some stuff. And we will plug something in just a minute. Over here to the side, I have a set of mixed matched solar panels. Now to make these things work together, what we have to do is I had to look at the nameplate to see what they're doing. And what I mean is on that is I either need to run them in series or in parallel. If their voltages are real similar and their amperages are very different, it's best to run them in parallel. In this case, I have two 20 watt panels and one 60 watt panel. So absolutely best to run them in parallel because the amperages are going to be completely different. Luckily for these ones, the voltages are all really close. Their optimal running voltage is within half a volt of each other. So we're not hardly going to lose any power in this weird Frankenstein solar setup. So how do we hook them up in parallel? Let me show you. Okay, on the back of these panels, I hooked up MC4 connectors. Now, to run them all in parallel, what's really nice, you can get these little adapters. Let you kind of plug them together, kind of like Legos. Really handy. And they just snap together. So in this case, I need to hook up 3 solar panels and make this sort of a wacky woo job. So how does it go together? Well, we'll start by attaching 2 of the panels together. And they sort of click into place. And you can pick up these little adapters anywhere solar products are sold. Amazon's pretty handy. These ones are Renology brand, I think, and they actually work pretty well. Others of their stuff ain't so great, but this stuff's good. So we have all of the black and red wires hooked up together. So they're all in parallel. So, whoops, sorry, got a bug chasing me down. Mosquitoes love me to death. So what's gonna happen is all the energy from these panels is gonna be combined and the amperage will be pushed up. Voltage is gonna stay the same, amperage is gonna go up. Okay, we have these all hooked up, running on my charge controller. Now, I'd have a much better answer of how well this is working at this exact moment if the sun would come back out. I've been fighting it with it all day. Clouds come out, I set this up, sun comes out for a little bit, clouds come back. So we're making the video with what we got. Sometimes that's all you can do. So this is our solar charge controller. This is a nice special one. It's called an MPPT. MPPT. The acronym sometimes gets me. What's neat about this is solar panels often run at a much higher voltage than what our battery wants to accept for charging. So in the old systems, what they would do is the solar charge controller is basically an on-off switch. And so what it'll do is it'll connect the solar panels directly to the battery to charge them. And they'll do that. The only thing is say the solar panels are outputting their best voltage at 17 volts. Battery wants to start at, say, 13 volts to get going for charging. Well, we're losing 4 volts. It could be as much as 30% off your power output of your panels. Really big penalty to take in. So that's what they have these nice little things for. These will take the high output of the solar panels and then convert it to the optimal voltage for the battery. So we don't lose all of that extra power the panels can provide. The other nice thing about these is when we run solar panels in series and we pump up the voltage, we can actually minimize the size of wire we're using. Old school solar systems would often use big, huge wires to get all of the amps they're trying to push in to charge all the batteries. Very big. However, modern MPPT controllers will run up to 600 volts. You can put a lot more power down a much smaller wire. Saves you a lot of money, more effective. Although, at 600 volts, it will shock the crap out of you, so be careful. This, since we're in parallel, we're only dealing with about 20 volts. Not nearly as dangerous. Here is our inverter. It's just a standard 12 volt inverter, and it takes 12 volts and will output 115 volts AC. This is a sine wave inverter. I like sine wave inverters because it means I can run anything without any weird things, including like the fridge. If you run a fridge off of modified sine wave, it sounds a little weird. I'll have to make a video showing the sound of that, and really not good for the fridge. Now this is an interesting inverter. It's made by Morningstar. In fact, my MPPT controller is also made by Morningstar. This will output 600 watts of power for 15 minutes and 300 watts maximum continuously with no limit. Has no fans. Is completely passively cooled. What's amazing about that is because of that, the design is very simplistic. There's no parts to wear out that way. I have been using these for about 12 years, I think, and had no problems. They're great for little stuff. I mean, it's 300 watts up to 600 for a little bit, and so you have a bit of room. It's kind of surprising what you can actually get by with. And we'll show off one of those things. Another thing is on the little Morningstar controller we have here. This is a little 12 volt takeoff. You have a cigarette power plug. You can run anything you're used to running in your car. And on this one, I also have some USBs. So we can charge batteries with little USB chargers, phones, all sorts of little things like that. Very handy. This is an extremely simple solar system. Now what's nice about that is it's very easy to get started. You need a battery, you need an inverter, charge controller, solar panels. That's it. Not complicated. As like I said, you can go scrounge this up. Go to Harbor Freight, get some parts. You know, their solar panels, you know, for the most part, are just gonna be fine. I wouldn't recommend the inverter or the charge controller, but the panels, yeah, that's okay. Solar panels are very little that can go wrong on them. The only thing that usually is a major issue with solar panels is what kind of glass they're made of, if it's tempered or not. Tempered glass can take hail. Regular glass, not so much. But there is always a limit. You get melon-sized hail, it's going through everything. Now, the other nice reason why I like old school 12 volt solar is, say, the world's falling apart, things are going wrong, I don't know, maybe we hit peak oil, there's no running cars, or very few. You know, because resources are scarce on oil, you know, nuclear war broke out. I don't know. But if we're trying to build little shacks and electrify them, or houses and electrify them, well, we can scrounge stuff out of cars. 12 volt is everywhere. And it's filled with all sorts of lights, switches, and everything else we can use on 12 volt. So having an old school 12 volt solar, even while there's a lot of limitations with it, can be really handy. And so we're going to expand and grow this system and make something really pretty impressive out of it and show you how amazing what we can actually do with 12 volt solar. Now, it will not compare to my big system, which uses 24 volts, or the bigger one I'm going to put together, which is 48 volts, but still, 12 volt can do a lot. And so I hope you enjoy this. So let's see what we can run right now on this little tiny bit. All right, got a rice cooker here, and we're gonna make some rice. Believe it or not, this will work. It actually works quite well. I have cooked rice on these little tiny solar systems lots of times. So let's see how much power and what's going on. So I've got a little clamp meter here, and this thing will tell me how many amps is flowing through the wire. Pretty well. No idea if you can actually see this, but it's showing me I've got 23.3-ish amps. Okay. Now, let's see what the voltage out of the battery is. Okay, our battery showing 12.30. Okay, so if we take 23, let me get on my phone here and I'll tell us. So we have 23.3 amps times 12.3 shows 286.59 watts. So what a watt is. So watts are determined by voltage time current. And so that's how much watts this device is consuming. Well within budget. That also accounts for the slight inefficiency of the solar inverter itself, because the inverters aren't 100% efficient. And when they usually get close to their maximums, they start dropping a bit. But this will work. Now, while I'm setting this up and doing these things, let's charge the phone. That's easy enough. So, got a phone plug adapter, and this one's got a quick charger feature. As you can see, this maybe wasn't picked out by me. Might have been girly. And it's charging. In fact, it's saying it's fast charging. This is good. And so you could see how a little tiny system like this could provide some power. Now the total output of the solar panels is 100 watts. So if we have good sun, get about 10 hours in a day, because I'm in the Southwest and we get a gob of sun. That's one of the best resources I have out here is sun. We're gonna have lots of videos about sun power. But, this thing could make, a kilowatt in a day, 1 kilowatt hour. That's tiny, but let's see what we can run on that. We'll hook up another panel later, and so we'll have 200 watts. Wow. And we'll put another battery in there and some more inverters and expand it. Plus, the other thing that we really need to add that is missing here is fuses. We have no overcurrent protection. So if anything goes wrong here, I'll be trying to weld wires. Not a good thing. In fact, very important. But I wanted to show everyone the absolute basic pieces to get a solar system going. And if I had to run something this way because it was the only thing I had to, I'd do it. No problem. I'd keep it out in a way so if something went wrong, it wouldn't burn my place down, but I would definitely make use of it. So we'll wait for the rice to cook. Rice is ready. Well, since the bird flu infected alien clown zombies have been destroying everything, gotta eat the rice and beans. Tonight's rice. Oy, I don't know how long I can take this. Now in truth, these little tiny rice cookers can cook all sorts of stuff. They're actually really handy, just like a crock pot. Now, generally, cooking with electricity isn't exactly super energy efficient. In fact, it's horribly energy inefficient. And so, much better to build and use solar ovens and such, which we'll be doing later. And I'll show you how I'll do it. It'll be fun. But for now, I'm gonna eat, and I hope you like this video. So, get out there, imagine something, and then manifest it. Thank you for your time. Bye. The cat's chewed on one of these ends. It's filled with teeth marks.